Hey, Mohammed. So, I was just reading through this report, State of Quantum and Financial Services, and honestly, it's pretty wild how fast things are, eh?
Ah, Emma, yes, absolutely. It's truly fascinating. We're seeing this massive shift, not just from, curiosity, but to actual committed pilots. Financial institutions, they're not just thinking about quantum anymore, they're doing it. It's a very exciting time, really.
Right? It's like suddenly everyone's diving in. The report mentions two main tracks, quantum secure finance and then these computational pilots. Can you break that down a bit more? What are those two really about?
Of course, of course. So the first track, quantum secure finance, that's all about protecting our data, our transactions. It involves post-quantum cryptography, or PQC, quantum randomness, and even quantum key distribution. Basically, making everything unhackable by future quantum computers, which is absolutely critical. And the second track, the computational one, that's where we get into things like risk modeling, pricing, optimization, solving really complex financial problems much faster than classical computers ever could. It's about speed, yes?
Wow, so it's both defensive and offensive in a way, like protecting us from future threats, but also giving us super powered calculation abilities now.
Precisely. It's a dual approach. And regulators, they're really pushing for that PQC migration, which tells you how serious the security aspect is becoming.
That makes total sense. And the report really emphasizes security, like with regulators pushing PQC migration. It also mentions how certified quantum randomness is like the first finance grade quantum native capability. What does that mean for, a regular bank customer?
Ah, a very good question, Emma. When we talk about certified quantum randomness, it means we're getting truly unpredictable numbers from quantum processes, which is just paramount for robust encryption and security. Think of it like this. If you have truly random keys, they're almost impossible to guess or crack. For a bank customer, it means their data, their transactions, everything is becoming exponentially more secure. We're seeing, for instance, JP Morgan and Quantinium already achieving this. And then you have countries like the UK investing a massive £121 million in fraud and AML quantum programs. They're really serious about this. Or Singapore, where MAS, the monetary authority, mandates PQC readiness across the sector. It's not just a suggestion.
Whoa, so it's not just about an abstract concept, but actual real world money being poured into this for very practical things like fraud prevention. That's pretty wild. And countries like South Korea too, with Shinhan Bank testing QKD. It's really a global race, isn't it?
Absolutely, Emma. It truly is a global effort. And the UAE, for example, they've launched a quantum secure communications testbed. Everyone is trying to stay ahead.
Okay, so the security side is clearly a huge driver. But what about the computational pilots, like the risk modeling and optimization stuff? What kind of advances are we seeing there? Any cool examples?
Oh, tons, Emma, tons. This is where things get really exciting for efficiency. Take Spain, for instance. CaixaBank is cutting hedging times with D-Wave's quantum annealing. And BBVA, they're piloting with multiverse on portfolios. That's huge. Imagine optimizing vast portfolios in a fraction of the time. In Canada, BMO joined the IBM Quantum Network for pricing and risk optimization. It's about getting faster, more accurate results for better financial decisions, right? Even Brazil, Itaú Unibanco, they're using quantum ML for churn prediction. It's incredibly practical.
That's wild. So it's not just theory, but actual banks getting tangible results. And what's the outlook for, say, 2026? Are we going to see full on quantum banks or what's the prediction?
Well, the report suggests that security-first adoption, things like PQC and quantum randomness, will outpace compute advantage in production a bit longer. Full fault tolerance, for truly massive quantum compute, is still years away. But hybrid solvers and quantum-inspired methods are already delivering incremental value. We're definitely on the path. Progress is undeniable.